today we'll be doing the integral from 0 to infinity of e to the negative x squared power divided by 1 plus x squared dx. And to start off, we will make a substitution. So we're going to let r equal 1 plus x squared, but that means that r minus 1 equals x squared. Solving for x, we have x is the square root of r minus 1, and differentiating, we have dx is 1 over 2 times the square root of r minus 1 dr. The bounds of integration, r1 will be 1 and r2 will be approaching infinity. So we're going to have the integral from 1 to infinity e to the negative x squared. That's r minus 1 over r times 1 over 2 times the square root of r minus 1 dr. We could rewrite this as the integral from 1 to infinity e to the negative r times e over 2r times the square root of r minus 1 dr. But that's e over 2, the integral from 1 to infinity e to the negative r over r times the square root of r minus 1 dr. And from here we could define f of alpha is e over 2, integral from 1 to infinity e to the negative alpha r over r times square root of r minus 1 dr. And then we would differentiate with respect to alpha. So we have f prime of alpha is e over 2, the integral from 1 to infinity of negative r e to the negative alpha r divided by r times the square root of r minus 1 dr. And these r's cancel, so we're going to have f prime of alpha is negative e over 2, integral from 1 to infinity e to the negative alpha times r over the square root of r minus 1 dr. And we'll make another substitution, so we're going to let s equal the square root of r minus 1, but that means that s squared plus 1 equals r, and dr is 2s ds. The bounds of integration, s1 will be 0 and s2 will be approaching infinity. So we're going to have f prime of alpha is negative e over 2, the integral from 0 to infinity e to the negative alpha s squared plus 1 divided by s times 2s ds. Notice that the 2's cancel and the s cancels as well. So we're going to have f prime of alpha is negative e, the integral from 0 to infinity e to the negative alpha s squared times e to the negative alpha ds, which is the same thing as negative e times e to the negative alpha, the integral from 0 to infinity e to the negative alpha s squared ds. And this integral is just the Gaussian integral, and we will recall that the integral from 0 to infinity e to the negative alpha s squared ds, this is just evaluates to the square root of pi over 2 times the square root of alpha. So plugging in here, we're going to have f prime of alpha is negative e times e to the negative alpha times the square root of pi divided by 2 times the square root of alpha. And recall we said f of alpha was e over 2, the integral from 1 to infinity e to the negative alpha r over r times the square root of r minus 1 dr. And notice f of 1 is the integral we want, and f of infinity, as alpha approaches infinity, this entire integral will be 0. So we're going to have 0. And so now from here we will integrate both sides of this expression from 1 to infinity. So alpha is going from 1 to infinity. So we're going to have the integral from 1 to infinity f prime of alpha d alpha is negative e times the square root of pi over 2 the integral from 1 to infinity e to the negative alpha over the square root of alpha d alpha. So we're going to have, this is just going to be f of alpha from 1 to infinity, but that's f of infinity minus f of 1. But we said f of infinity is 0, and f of 1 is the integral we want. So we're up minus I equals negative e times the square root of pi over 2, the integral from 1 to infinity, e to the negative alpha over the square root of alpha, d alpha. And notice that these negatives end up canceling. So we're left with our integral is square root of pi times e over 2, then the integral from 1 to infinity, e to the negative alpha over the square root of alpha, d alpha. And from here we'll make one last substitution. We're going to let t equal the square root of alpha, but that means that t squared equals alpha. D alpha will be 2t dt, and notice that the bounds of integration here will not change. So we're going to have the integral is square root of pi times e over 2, and then the integral from 1 to infinity, e to the negative t squared over t, d alpha is 2t dt. These 2's end up canceling, and these t's end up canceling. And we're left with square root of pi times e, and then the integral from 1 to infinity, e to negative t squared dt. And we will use the following fact that the complementary error function evaluated at u is 2 over the square root of pi. The integral from u to infinity, e to negative t squared dt, but that means that the square root of pi over 2 times the complementary error function evaluated at u is the integral from u to infinity, e to negative t squared dt. So plugging in u equals 1, we'll have the square root of pi over 2 complementary error function at 1 is the integral from 1 to infinity, e to negative t squared dt. That's exactly the integral we're looking for here. So we're going to be left with I is the square root of pi times e times the square root of pi over 2 complementary error function at 1. And so therefore I is pi times e over 2 complementary error function at 1. So that is the final result to this integral. Thank you very much for watching.